In this section, we'll give an overview of exceptions and exception handling. When a piece of code may throw an exception, that piece of code can be wrapped in a try-catch block. The possibly offending code goes into the try block area, and the try keyword basically says, let's try this and see what happens. If an exception is not thrown, the try block continues and executes to the end like any normal block or compound statement. And when finished, all of the catch blocks following it are skipped. If, however, in the try block, a piece of code throws an exception, then the try block immediately terminates and any catch block in sequence is tried, and the first one to match gets a chance at executing its body. If no catch blocks match, then the exception is thrown up to the method that invoked this particular method, and it is given a chance to handle the exception. If it still isn't handled, it may be thrown all the way back to the Java virtual machine, which will just terminate the program. The try block that has multiple catch blocks must order those catch blocks in a particular sequence. The most specific catch block must come first, and the most general must be last. What this means is a general catch block can catch any number of exceptions if they're of a particular family. The specific catch blocks are one, maybe two exceptions. If they were reversed, where the more general was first, it would catch the bulk of the exceptions, and the specific ones, which would be ordered at the bottom, would never be able to execute, and the compiler will throw a syntax error saying that that code is unreachable. So the most specific to the most general. We must think carefully when designing any method that might throw an exception. While some methods can return a 0 or null value to specify that something went wrong, others can't return any such thing and make it meaningful. For example, let's imagine that a method was written to input an integer value from the keyboard. Let's assume further that what was typed was something like the word dog. That's not an integer. It wouldn't convert to an integer. An exception would be thrown. Technically, an input mismatch exception. Well, what would that method return? It can't return a 0 because that could be a legitimate integer value, but that's not what was entered. Can't return a negative value because that, again, may be a legitimate value. So there's no way to return a good value. The best way is to throw an exception. Now, of course, the other option is have the method loop looking for good input and not return until that input is there. That's a different option. We still have to deal with input mismatch exceptions, however. That would be handled within the method. Another example is a method that divides integers. If it finds that it divides by 0, an arithmetic exception will be thrown. It must be handled somewhere. What would be a meaningful return value from such a method? Obviously, 0 again is not the right answer. Since division by 0 with integers is undefined, an exception is the best option. Some programmers, upon discovering exceptions, try to use them for all sorts of uses. They should not be used in general, only for exceptions or specific cases. Normal operational conditions should be handled with selection logic, not exceptions. However, when dealing with programs that exercise code in the operating system, input, output, and various other environmental manipulations, exceptions happen. Our code needs to be able to handle them. That code should be in try blocks with appropriate catch blocks following. If not, the termination model, which is default, will occur and the program will be stopped cold. If we properly craft our code with try and catch blocks, we can catch those exceptions and do some form of recovery, at least write out a log message that says what the problem is before the program gets terminated. Help your user understand what went wrong. Don't just allow termination. I mentioned before a case of input mismatch exception. That could be handled in a loop inside a method, and the method would return a good value because it would not return until a good value was entered. Other times, that's not practical. We just have to throw the exception. It takes experience and practice to learn the best approach. Just work with it. Over time, you will develop that. The location of where we handle an exception takes experience and deep thought. The example I've given is the input loop that catches the exception and repeats the prompt asking for valid input and doesn't return until that occurs. That is one approach. Another is to make sure those methods that throw exceptions, throw them in the context of a calling or invoking method, which is expected to handle them. Sometimes the method itself can't appropriately deal with an exception, so it just throws it or allows it to go up to the invoker. There, the invoking code may anticipate such an exception and put in handling code. The semantics of the code, that is the meaning, what each method means in context with each other, determines to a large part where we handle an exception. This doesn't come easily. You have to learn and grow in your skill to get it. Careful design should determine where in the hierarchy of method calls we put exceptions. But again, it takes time and experience. Start with exception handling within the same method, and then as you grow, learn how to do it in calling methods.